Now we are the team number 1, and our team name is NordCoders. My name is Otebe, so I will be presenting our solution for the given task challenge. Our application is called Noise Monitoring System. Okay. Now this is our team, and in our team we have me, Jamil, Fatima, Babu, and Vanya. And this is Fatima. So now this is the content. So first we will describe the problem and we will propose our solution. After that we will explain the architecture of our solution. Then we will show the demo. Then we will give you some future work, plans, and use cases. Like how can we use our application in real world scenarios. So if you go, what is the problem? So as we said, as you said before, teachers are reporting the noise level in the classrooms are high, and they are reporting. So the noise is annoying them. So we need to propose some kind of solution. But the thing is, it's only annoying. Maybe it's not enough. I think we need to go deeper. Maybe it's harmful on our health. So at that point, we need to face our expert, researcher, Fatima.
Okay, so I'll talk. So we spoke to a daycare center as well as we have done a literature review, and we have found out that lots of contemporary studies have pointed out that there is a detrimental effect on both the students as well as the teachers when they're exposed to loud noise. Furthermore, this causes educational impairment as well as psychological and health impairments. It is repeated exposure to long noise, even if it's at a lower level, can cause hearing damage, especially for young kids. And continuous exposure about loud noises can cause lots of mental disorders such as feeling high levels of stress, anxiety, depression, fatigue, and so on. And now I will talk about the solution.
So our solution. Okay, let's pay a little bit more attention. So our solution is, we call our application noise monitoring application, and what it does, actually, let's see. It shows the indoor noise level in the classroom. So we will get real-time data on our application. We can see the noise level on our application. What else? We categorize the noise level into 3 different levels. So we can say, and we may conduct some research on the noise levels. We will explain in the later slides for easy understanding. It's the application is really human intuitive. Like you don't have to have any user manual, anything. You can just see and understand the application. And providing suggestion based on the noise level. We did research, so we found some suggestions. And so if you have some exposure to prolonged noise, really high levels of noise, you will have some kind of bad effects on your health. So we will give suggestions on that as well. And historical noise data. So we can see the historical noise data in the classroom. Let's say 1 hour ago it was like this, or just now it's like this. And I will explain the architecture. I hope everyone understands. So we have our classroom. In our classroom we have Arduino. In Arduino we have our microphone sensor. So it senses the noise. It's just regular stuff. Then it senses the noise, and it reads the data, converts to decibel, blah blah, and it uses JSON format to send the data to our proxy server. And we will send the data from proxy server to SSIO platform. It's IoT platform to store our data. The thing is, we yesterday showed that Arduino sends the data to directly SSIO platform. We changed the architecture a little bit, so Arduino sends data to proxy server because on the proxy server, we use machine learning. We have plugin machine learning security handling, so we can do these steps, which means we can analyze the data before sending to IoT platform. And let's say we have client teachers, probably, and they will access the web page and they will request to the proxy server, and proxy server retrieves the data from the SSIO platform, and it responses to the teachers. Now, tools and technologies, we use Python regularly. So then we use Arduino platform and Plus framework based on Python. And for user interface, we use just web application. So here our research results on the effects of noise on health. So I will,
Okay, so yesterday we were asked by Murtaza to show how we got the values. So based on that, we did some research to show how we got the values, how we set the levels and the parameters. So based on WHO guideline, it can be seen that for 35 dB, it can cause a bit of speech intelligibility, it can cause communication disturbance for school class, and for the classrooms where they sleep or the nurseries where they sleep, it can cause sleep disturbance even for 30. And the maximum that we can reach without harming children is said to be 45 dB, and this is according to WHO guidelines. Moving on, we did some more research on the noise levels data. Let me just show them. So according to NIOSH, we have found out that the 80 dB is prolonged exposure to 80 dB can cause harm, and the occupational OSHA, the occupational safety, this is for industrial level, it is said to be 85 dB for 8 hours on average. 8 hours on average, and below, above that we shouldn't go. And 90 dB is the absolute maximum for industry levels. This is not for children though, we're talking on a general term, and we are talking about industry levels. And we have found out another interesting research that for every 3 to 5 dB increase, it is said that the duration of the exposure should be cut in half. So collecting all of this information, we have decided to set our parameters. So the different noise levels is, because ours was aimed at children, at least our main use case was for children in a daycare center, we have said that 0 to 35, we are assuming it's safe, and 35 to 60, it's annoying, but above 60, we are considering as hazardous. Now we can move on to the demo.
Okay, it's a video, we need to play. So let me change the mouse.
Is it moving? Yeah.
Yep. As you can see, this is our main GUI. You have the main monitoring card, if you say. So you will see the latest result in the user readable form. So if you get the green color, which means it's safe noise level, and if you have warning, it's warning. Alarming, it's really loud. So here the noise level is changing. We reached the level threshold, first threshold. That's why the color changed. And based on the color, we will have like noise level is safe now. Great job, dear teachers. And for extra information, you can go to the links. There are buttons. If you click, you will go to the research papers or websites. We collected our information. And so, yeah, we'll have the real-time data. I think we finished the video.
Yes.
And inform button, like if you click the inform button, so when you reach the noise maximum threshold, so it will inform you with voice. We will show in the real demo. This is just a video.
Sorry, we're experiencing some technical difficulties.
Yeah.
I can ask a question while you're fixing that. Yesterday you talked about detecting music to.
Yes, we are going there.
Yeah.
Yes, we are going there.
We're going that far.
We are going there.
We didn't finish yet.
Yes.
As soon as we get the PowerPoint working, and it seems to be working now.
There you go.
Okay,
Yes.
we're going.
Okay, so now we want to add some intelligence to the system that we have demonstrated so far. Sorry, where's it?
Use this one. Button.
Thank you. So how can we make it intelligent? Based on the proposal by my teammate yesterday, was that we were going to detect whether it's a noise or a music based on the pattern of the sound wave. So we did not collect enough data, or we could not collect, if you want to do machine learning as proposed by my teammate, we could not collect enough data in 2 days for that. So we used the most popular data set for sound system, which is Urban Sound 8K. And we used 2 machine learning or deep learning algorithms, which is CNN and RNN, to finally get the following results, which is we can detect the different wave plot. We can see the wave plots of different sounds. For example, if you can see that street music, it has kind of a consistent pattern, whereas siren, which is more annoying, it has lots of spikes. And for example, dog barking, it has lots of spikes. So based on these features as well as other extracted features from the sound data itself, we can differentiate between 10 different types of sound currently, which is air conditioner, car horn, children playing, dog barking, drilling, engine idling, gunshot, jackhammer, sirens, and street music. But we did not connect this to our platform, but this we have already implemented. If you want to see, we can show the demo. Okay, so moving on, I'll talk a little bit about the future work that we are intending to do. Because we could not collect enough data, we could not do all the labelings by ourselves in the middle of the hackathon, which is why we did it on a already processed data set, but we can easily plug it into our proxy server, which is why we introduced a proxy server as explained by my friend. Furthermore, we will be creating a mobile application for the solution that we have proposed. Now let's talk a little bit more about the use case where we can use our system. For example, we can use it in a smart classroom system because our studies have shown that there is a direct correlation, there is not a correlation, but there is a relation between the lights as well as the as music for children and the noise levels. So what we can do is, if we have a smart system based on the noise level, which we will integrate with machine learning as well as children's behavior pattern, we can, if the children are making lots of noise, we can kind of dim the light, we can play lullabies to calm them down. Because we're talking about children, they're not crying because they want to cry, something's agitating them, which is why they're crying, which is why we want to calm them down. Instead of adding pressure on the teacher, we want to do it automatically, which we can do with the smart classroom system based on our proposal. Furthermore, using our noise level application, we can integrate it with the traffic system. What this means is we can monitor this, we can build policies so that we can monitor the noise level around hospitals, schools, as well as old homes, so that these people, they're not affected. But to do anything first, we need to monitor. And our application will help in monitoring, because we're monitoring, we can then build policies on that. Furthermore, this also has an industrial implementation. For example, industries with heavy machineries, as well as vehicles and constructions, we need to ensure that the maximum level does not increase 85 to 90 dB over 8 hours a day, because this violates labor laws as well as human rights laws. With our application, we can monitor this, and we can ensure that the company is not violating any act over an 8-hour period, because this is the maximum recommended level. one more thing is we have implemented, we don't even need a particular specific sound sensor, because we can also, we have already implemented using our laptop, just our laptop microphones. So it's very scalable and versatile. Okay, I think we've taken up enough time. So these are the references that we have used. If anybody is interested, we can take them. Finally, the presentation is finished. Thank you.
Two seconds real demo.
Okay, yes, you can ask questions in the meantime.
Yeah.
Okay, so my question is like, for your first and third use case, like when you work in industry or for schools, if there is, the noise is too much, it's actually harming the kids in the real time. In that case, like in your case, it's like a batch processing. If someone requests, then you'll get response.
No, we're getting real time. It's in real time.
But for that, you need to ask for the.
No, we're not asking. You can continuously see.
So it will provide some kind of notification or alarm.
We wanted to go for notification or alarm. If the teacher wants, then only she will get the notification. Because the way we thought about it is, if a kid is crying or if there are multiple kids shouting, in the middle of that, if you give a siren, the teacher will be more annoying. So that we wanted to make it more intuitive for the teacher, that the teacher can see that something is happening. So, and we're also thinking about SMS notifications or email notifications. But in some daycares, in some schools, the teachers are not even allowed to use a smartphone when they're with the children, which is why we opted out of the smart notification. And because we're talking about children, which is small kids, we are thinking that a teacher won't be sitting in front of a laptop all the time to get email notifications, read email notifications. And we don't want to force the teachers, we just want to provide soft suggestions, because they're already so stressed. Our use case, the people who will be using our applications, at least for the first use case, there will be teachers. We don't want to add stress on them to control the noise level. We just want to give soft suggestions, which is why we did not go for hard-coded inform me, but we have we have a notification which Otabek will demonstrate.
So this is our user interface, as you see it. Based on the current noise level, we will have some kind of research results. The resources, you can go to there and you can read more information as you need. And you have guidelines, CDC guidelines and WHO guidelines. You can see this one as well. And here the bar chart is like real time, so you can see the last value is like just 5 seconds ago. Was then.
We can't hear the sound from your laptop. I think we turned it off.
Okay. Then we can change the rooms, and like if let's say we have sensors in other rooms, we can change the rooms and go to the other room, monitor the other room. Like from different room, we can monitor the other room in which kids are playing or studying. Thank you. That's it, I guess.
Should I speak again? Sorry, I have a question.
Yes.
Talking about the machine learning, from what I understood, you didn't implement it in the project.
We did not connect it to our project. We have a fully implemented version. Let's be clear about that.
Okay, but like, did you guys try out some sound APIs? Like, you don't need a lot of data. You have data sets already, so you can just call APIs and use it to.
No, but we did not want to connect to this one because it would disrupt our main use case. It was a different use case, which is why we kept it separate.
Yeah, the main focus is the classroom noise, but the dataset we got is for different type of sounds, not specifically for classroom.
Exactly.
Yeah,
so we need to. So there is no specific just classroom sound database, which is why we needed to use one which is verified. It's one of the largest data set. It is used by numerous papers. We do not want to use a non-valid data set. The APIs that you're suggesting, some of them they are not supported by research. The one that we are using, it is one of the largest data sets and the most used.
Well, Google API is like widely known everywhere, so it's using the Google Chromebook and all those, like their own AI. So the API is like accessible, and with your data set you can
No, but the
compare.
way we wanted to do it, it's what we are trying to do is not the same thing as what Google API is trying to do. It's a different thing.
Yeah, the main focus of our project is to monitor the background noise level of the daycare centers, especially the classrooms of the daycare centers. So particularly for this, we can implement by our own. We can collect the real-time data so that our machine learning model will be like more accurate, because we are getting
Our machine.
Type of noise or sound.
we already did the type of noise like dog barking or the siren or the driller going on or the air condition running in the background. We already did.
Those are the same functionality securities, because like we also
Okay, I think we're already taking way more time. We can continue this discussion later.
Great, thank you very much.
Thank you.